Hi GCSE Maths class. I'm going to do a video here for you this week just to give you some more theory from the course regardless of the mess of things, and it's on quadratic graphs. I will explain all very shortly.
When numbers get serious, you see their shape everywhere, dividing and multiplying.
Hopefully you remember a couple of weeks ago we did some straight line graphs in class. There's an example, or there's my illustration of the graphs that we plotted out. That's 3 straight lines, and we talked about the equation of a straight line is in the form y equals mx plus c. M was the gradient or the steepness of the line, and c is the y-intercept where the line crosses the y-axis. Now, if we don't have that type of equation, in other words, if we don't have y equals mx plus c, we might have a quadratic equation instead. And a quadratic equation is one that has an x squared in it, like that. Now, we also need to be able to plot graphs from equations of that type. And I'm going to do the same sort of method as we did when we were working out how to plot a straight line. In other words, I'll do out a wee table with x's and then use that as a recipe for y. Okay, so there's my wee table, and because it's a more complicated rule, I've broken up the table into more rows than we had before, so we don't have to work out the y value all in one go. Because the y is made up of x squared plus a 7x plus 10, I've done out a row for each of those terms. Now, as you go across the x's, hopefully you can say what x squared is. If x is minus 8, x squared is 64. Now remember, that would mean a minus 8 times a minus 8 to square it. You always multiply by the number itself, you multiply a number by itself when you square. And if you start with a negative number, that means you're multiplying 2 negatives together, so the answer is positive. So in the same way, minus 7 squared is 49, plus 49. Minus 6 squared is 36. So there's that row filled out. The next row down is indicated there, it's 7x, that means 7 times x. Now, 7 times x in the first column here is when x is minus 8. So 7 times minus 8 is minus 56, because in this case you're multiplying a plus by a minus. And again, we did say this, if you multiply a plus by a minus or a minus by a plus, you get a minus answer. 7 times minus 7 is minus 49. 7 times minus 6 finally, we're just saying 7 times 1, which is because it's plus 1, the answer is now plus 7. And the last row is easy because there's no x's involved, it's just 10, which doesn't change. Doesn't matter what x is because it's not made up of any x's. And then to get the bottom row, which is really the thing that we want, the y's, we go to the middle 3 and combine them, like add them. So 64 minus 56 is 8, plus 10 is 18. 49 minus 49 is 0, plus 10 is 10. 36 minus 42, well, you're taking away more than you start with there, so you're down into the minuses by minus 6. So that's minus 6 plus 10 is plus 4. I'll fill out the rest here. You can look and check and see if you agree. Okay, so here's my axes ruled out. Remember, x's go across and y's go up and down always. And here's the points that we want. Remember, it's the top, I've highlighted them there. It's the top row and the bottom row that we want to plot and then join them up and see what we get. We won't get a straight line this time. So up here, when x is minus 8, y is 18. And remember how points are plotted. Go across to the x first of all, and then go up or down to the y. So I want the x at minus 8 and the y up at 18. So then I put a point so there's all the points plotted in this one. Now I'm going to join them up. They're not in a straight line, so don't rule between points. It's not a collection of straight lines, it's one single curve. So try and draw, try and connect the line, try and connect the points with a single smooth line. I will try to do that now while it's not also filming it, and I'll show you my result. So there it is with the line drawn in. I'm not using a ruler there. I'm just connecting the points as smoothly as I can. That's the type of shape that you get when you plot a quadratic equation, and it's called a parabola. Now, one thing to say is, if you take the equation that we've been plotting, there it is, and if you turn that into, that's really a kind of a relationship between x's and y's, and so we've shown that on the table, and then we've indicated it on the graph. But if you make it an equation to solve, if you make the y 0, then you end up with 0 equals x squared plus 7x plus 10. Now, our graph can actually help us solve that, because if you make the y 0, what you're saying is you're on the x-axis. Along the x-axis, the y-coordinate is 0. And so another name for the x-axis is just the line y equals 0. So if you make y equal to 0 in an equation, then you'll find out where the graph crosses the x-axis. So the solution to our equation, x squared plus 7x plus 10 equals 0, corresponds to those two x's there, minus 2 and minus 5, where the graph crosses the x-axis. So by my graph, I can solve that, which is x is minus 2, or there's two solutions, or x equals minus 5. Now, I did do a video on solving what are called linear equations, where you don't have x squared terms, and they all had one solution. But an equation doesn't necessarily just have one solution, or even any solution. And quadratic equations can have no solutions, one solution, or two solutions. And it always depends on where their graph crosses the x-axis. Because a graph can cross an x-axis in two places. It can just touch it in one place if that's the lowest point on the graph, and it doesn't have to cross it at all. So those are the three situations where you either have two solutions, one solution, or no solutions for a quadratic equation. Okay, I'll do a second example here for you, just because there's more minuses involved in this, just to illustrate that. So if you had that quadratic equation, that's y equals x squared minus 5x minus 24. Then I'm setting up the table here with x's along the top, going from minus 3 to plus 8. And I will fill it out. Now, the x squareds we covered in the first example, you probably get that okay. Remember, when you square anything, even if it's negative, you get a positive answer. So the answers to the x squared row are okay. Now, be careful here. This is what I wanted to illustrate with this example. Here we have now minus 5x. And remember, if you multiply by a minus, you always get a plus. So we're saying here for the first position here in this row, minus 5 times minus 3, which is plus 15. Next would be minus 5 times minus 2, which is plus 10. Minus 5 times minus 1 is plus 5. 0 times anything is always 0. Now into the plus x's, the answers now become negative because now we're multiplying a negative by a plus. So minus 5 times 1 is minus 5. Minus 5 times 2 is minus 10. So there's the rest of my table. I still need to work out the y's so I can plot the graph. It's got a bit messy there at the end, so apologies. I'm going to just try and run with it. Here I'll do the first few terms that are more clear to see. Remember, we're gathering together the 3 rows, and really what we're doing overall is adding. But if something is minus in front of it, then you take it away. So 9 plus 15 is 24 here. Minus 24 is 0, so the first y that you want is 0. Four plus 10 is 14. Minus 24 is minus 10. 1 plus 5 is 6. Minus 24 is minus 18. 0 plus 0 is 0. Minus 24 is minus 24. So there's my axes. Now on my y-axis up and down, notice what I've done. I've had to double up so I can get in these numbers because they're a bit bigger in this example. So I'm going 2, 4, 6, 8, but I'm still taking even jumps. I'm just making 1 centimeter jump of 2 on the y-axis, and then going into the minuses, minus 2, minus 4, minus 6, minus 8, minus 10, and so on. But that's because I need to get down to minus 30 on the y's for this example. And the x's, I'm just taking the same scale as I did before, which is 1 centimeter equals 1 unit on the x's. So it's basically plot the points. There they are again. Don't forget it's the green highlighted rows that I'm plotting. The top one is the x's, the bottom one is the y's, and I go across. X is minus 3, y is 0, so that means you're on the, as I was indicating before in the last example, when y is 0, you're on the x-axis. So when y is 0, x is minus 3, would be plotted there. I should really think of the x first, but I think x is minus 3, go across to minus 3. But then since y is 0, I neither go up nor down. And so when y is 0, I'm on the x-axis. The next value was minus 2, goes with minus 10. The next value, minus 1, goes with minus 18. Now when x is not, I'm on the y-axis, and at y equals minus 24 in this example. So here we are, there's the graph plotted, the points plotted and then joined up, not using a ruler, just draw it as smoothly as you can because it's representing a curve and not a collection of straight lines. Now, again, we can see we've made it more clear in this example. If we were to solve the equation 0 equals x squared minus 5x minus 24, now remember that would be the same thing as x squared minus 5x minus 24 equals 0. So we're asking, when does this graph cross the x-axis? In other words, what are the x's that make the y 0, or that go with a y of 0? And again, we can see it here. We've got two solutions. X is -3 or x is 8. If you kept on working out points, like, the graph would continue, but I'm just plotting the points that I've put on my table. So that is quadratic equations, which when you plot them, they give you parabolas. The shape of these graphs is called a parabola.
Flight E07, you're clear for landing.